Okay, in this video I'm going to show a couple of example problems that are dealing with loss calculations in transmission media and uh, using the decibel units in those calculations. Okay, the basic equation that we'll use, let me add a title here. The basic equation that we're going to use is the following. We're going to say that the power out is equal to the power in minus the loss. And I'm going to put dB subscripts on all of these, all three of these quantities, to make it very clear that they all have to be in decibel units. Okay, so the system, the physical thing we're looking at here is some power going in to some transmission media, and then we're interested in how much power comes out. Okay, this is very fundamental to communication systems and networking in general. Everything from 802.11 Wi-Fi networks to Ethernet cabling to fiber optic transmission over long distances. Okay, and in general, we're interested in the output power because the output power helps determine how well the signal is received at the receiving station. Okay, and if we have all three of these quantities in decibel units, the calculation is as simple as this. Okay, first of all, realize that a positive loss value indicates that P out is less than P in. Okay, and that's clear by this minus sign here. And so, for example, if the loss is 10 dB of a particular transmission media, and the input power is 15 dBm, meaning 15 decibel milliwatts, then we can calculate the output power very simply. In dBm is P in minus L, which is 15 dBm minus 10 dB, which is 5 dBm. Now, we're mixing dBm and dB. That's perfectly legitimate, and that's what we do in these types of calculations. Okay. These problems get trickier if either or both of the input or output power is measured in milliwatts, either given to you in milliwatts or asked for in milliwatts, or if the loss is given to you as a loss ratio. So, for example, the loss ratio corresponding to 10 dB of loss is a factor of 1/10. Okay, so this means that 1/10 of the input power makes it to the output. Okay, and that calculation is simple. You say that using the conversion factors, the loss in dB is equal to minus log 10 of P out over P in. I'm going over the edge here. All right, there we go. Okay. So this is the loss ratio here. Okay. So as a second example, if we are given that P out over P in is 0.01 and P in is equal to 20 milliwatts, calculate P out in milliwatts. Okay. The first thing I'm going to do is I'm going to say that the loss is equal to minus 10 minus log 10. Yeah, it's 10 log 10. It is 10 log 10. Sheesh. Of 0.01. And that is, the log base 10 of 0.01 is -2. And so this is 20 dB of loss. Sorry, I wrote the equation wrong up there. And I'm also going to convert the input power from milliwatts into decibels. And it's going to be 10 log 10 of 20 milliwatts over 1 milliwatt. And I can do that on my calculator. I'm going to go 10 times the natural log, log, not the ln, of 20. And that's going to give me 13.0 dBm. So that's these powers are in dBm units. Okay. Oops, sorry. And so I can calculate P out. Now, it's equal to P in minus the loss in dB units, which is going to be 13 minus 20, which is -7 dBm. Okay, and I can convert -7 dBm into milliwatts as follows. I take -7 and I say I'm going to take 10 and I'm going to raise it. Let's see, I have a 10 to the x button on this calculator, so I can go, I may have to figure it out, 10 to the -0.7 equals, and I get 0.2 milliwatts. Okay, and that makes sense because it is 3 dB above -10 dBm. -10 dBm is 0.1 milliwatts, and 3 dB up doubles the power. Okay, so there's a couple examples showing one very simple and another one where you have to do some conversions first. Hope that helps on the homework.